Welcome to The Explainer. I'm your host and resident language assessment expert, and today we are unpacking Chapter 7 of Ake Piketty's foundational text, Language Testing and Assessment. We're zooming in on what is arguably the most notoriously difficult skill to measure out there, testing and assessing listening. I mean, think about it. Unlike reading, where the text is literally right there on the page, or speaking, where you can actually hear the output, listening is completely invisible. You can't just see the cognitive wheels turning inside a student's head. So to make this explainer super dynamic, I'm joined by two fantastic co-hosts. Hi everyone, I'm currently a postgraduate TESOL student, and honestly, I'm constantly wrestling with how to translate all these dense testing theories into my actual coursework, without getting completely overwhelmed by the literature.
And hello, I'm an early career language teacher. I'm basically here to figure out how to take these high-level assessment frameworks and actually apply them to a classroom full of students who face very, very real anxieties and challenges during listening tests.
It is absolutely fantastic to have you both here. We've got a really robust seminar-level discussion ahead of us to help our postgraduate listeners truly master the art of designing valid, reliable listening assessments. So let's jump right into our roadmap. Okay, we are covering 5 key areas today. We'll start with a theoretical foundation of the nature of listening, and then break down the cognitive mechanics of bottom-up versus top-down processing.
Right, and after we get the theory down, we're moving straight into the application side. Matching purposes and task formats, which I definitely need for my lesson plans.
And then we'll tackle my favorite parts, selecting effective spoken texts and wrapping up with the assessment challenges and technology impacts that we battle in the classroom every single day.
Exactly. Let's get right to it.
All right, let's dive into Part 1, the nature of listening. As I mentioned, it's widely considered the most challenging construct to test. But what exactly makes the nature of listening so uniquely complex compared to everything else we assess?
Well, to really wrap our heads around that, it helps to do a quick callback to our previous explainer on Chapter 6, Assessing Writing. Written texts are permanent, right? If a student misses a sentence, they just reread it. The reader completely controls the pace. Exactly. But listening, as Chapter 7 explicitly details, is a totally different beast. Spoken text is transient. It literally vanishes the second it's spoken. Plus, everyday speech is incredibly messy. It's filled with redundant features, hesitations, ums and ahs, and false starts. Right, and they have to rely on real-time prosodic cues just to grasp the intended meaning. Think about how stress changes everything. If I say, "I didn't say that," it means something completely different than "I didn't say that." The student has to catch that nuance in a fraction of a second. That stark contrast really highlights the massive, immediate cognitive demand placed on the listener. You simply do not have the luxury of time. Which brings us to a formal definition of the construct we are actually trying to assess here.
Expert listening comprehension is a complex, real-time process where learners draw on multiple sources of knowledge, phonological, vocabulary, grammatical, discourse, and pragmatic, to construct meaning from spoken language.
It's definitely a dense definition, but grounding those multiple sources of knowledge into reality kind of clarifies it. If I play audio for a student, they aren't just passively hearing words. They're simultaneously decoding phonological sounds, searching their vocabulary memory, and mapping out the grammar, all at once.
Right, and that creates a major tension for construct validity. If a student fails a listening item simply because they didn't know one specific obscure vocabulary word in the audio, well, did we actually test their listening skill, or did we accidentally just test their lexicon? We have to be incredibly careful.
Oh, for sure. And don't forget pragmatic knowledge. They have to understand the social context, too. Like, is the speaker being sarcastic? Are they making a polite request? They're juggling all of this instantly.
But wait, that actually brings up a huge question for me regarding cognitive load theory. How does the human brain handle all this audio input and synthesis simultaneously during a test without completely crashing? That is the perfect question to move us right into Section 2, the cognitive mechanisms of listening, bottom-up versus top-down processing. To understand the brain's bandwidth here, we have to look at the interaction of 2 distinct mechanisms. Bottom-up processing is foundational decoding. The audio signal hits the ear, and the listener decodes the phonetic sounds, parses the syntax, and recognizes individual words to build up to a meaning.
But they aren't just starting from scratch, which is exactly where top-down processing comes in. This is using prior topical knowledge and context to predict meaning. In my classroom, if I tell my students they're about to hear a weather report, their top-down processing immediately activates vocabulary for rain, temperatures, and days of the week before I even hit play on the audio.
Okay, so successful listening isn't just one or the other. It's both of these interacting simultaneously. The predictions from top down actually help speed up the decoding of bottom up. Spot on. It's a two-way street. And this brilliantly sets up John Field's cognitive model of listening, which breaks this entire process down into distinct, measurable phases. Let's see how this builds across Field's 5 levels of listening. It starts with lower-order processing. Level 1 is input decoding, literally just converting acoustic sounds into syllables.
Then level 2 is lexical search. The listener takes those sounds and matches them to the vocabulary stored in their brain.
And level 3 is parsing, connecting those words into syntactic patterns to anticipate grammatical structures.
Now here's the profound insight for us as assessment designers. Those first 3 levels are highly bottom-up. Lower-level learners experience massive cognitive strain here because they are spending, say, 90% of their working memory just trying to segment sounds into words. They have zero cognitive bandwidth left for the higher-order processing.
Exactly. They literally can't reach level 4, meaning construction, where they interpret intended meaning, or level 5, discourse construction, where they synthesize the whole context, because their brains are completely overloaded by levels 1 and 2.
Which means if you're testing beginners, your assessment will inherently look very, very different than one designed for advanced learners who just breeze through those lower levels automatically.
That theory is fantastic, and it perfectly explains what I see happening to my struggling students. But let's shift from the theoretical models to the reality of task design. Moving into Section 3, how do we build assessments that accurately measure these very specific internal cognitive phases? We do it by ruthlessly aligning our listening purpose with our targeted construct and then selecting the exact right task format.
Look at it this way. If your purpose is general comprehension, your construct is assessing whether they understand the gist. A standard multiple choice format works well here. But there's a huge caveat with multiple choice, right? I mean, if the A, B, C, and D options are a paragraph long, we've accidentally built a reading speed test instead of a listening test. A massive validity issue, exactly. The reading load absolutely must be minimal. Now, if you want to assess specific information, your construct is detail recall, which pairs really nicely with short answer tasks. And for me, that integration purposes where classroom tasks get highly authentic. If I want to test inference, I absolutely love using an information transfer format. I might have my students listen to a lecture about ecosystems and ask them to complete a visual diagram with missing labels. It proves they can synthesize what they heard while completely eliminating heavy reading and writing demands. It's a real game changer. But wait, the task format is only half the battle. This brings us to Section 4. The audio clip itself completely changes the test difficulty. If I give my students a great information transfer task, but the audio is 2 people arguing over a terrible phone connection, they're going to fail regardless of the format. So how do we select the right spoken texts?
That is a critical insight. The selection of listening text is a fundamental design consideration that can literally make or break your assessment.
There are several variables we must systematically manage to ensure validity. First up is speech rate, words per minute.
We also have to scrutinize accents and cultural relevance. If a test relies on a highly obscure regional accent or some niche cultural idiom, are we testing general listening ability or just cultural familiarity?
As a teacher, the biggest tension is authenticity versus graded texts. We all want authentic, real-world audio, but it's messy. It has overlapping speakers and background noise. Fully authentic texts might be valid for advanced learners, but they're completely demoralizing and invalid for beginners. Often, I have to use graded texts, scripted to sound natural but carefully controlled for vocabulary and grammar, just to keep the test fair.
Exactly. It is a constant trade-off. And we also have to manage the length of the input because a 5-minute audio clip heavily taxes working memory, forcing us to decide whether the test allows for single or multiple plays of the recording.
So, the core takeaway here is that listening performance can easily be contaminated. Which brings us to our final section. The high stakes of external factors and technological variables that can confound our results. I see these external factors ruin test scores all the time. Sometimes a student scores poorly, not because their phonetic decoding is weak, but because of a broken classroom speaker, causing poor audio quality. Or high anxiety completely shuts down their working memory. Sometimes they fail in academic listening tasks simply because they lack basic note-taking skills.
Precisely. In assessment literature, we call these sources of error variance. And while technology has solved some logistical problems, it has introduced massive new accessibility issues. Take adaptive testing algorithms, for instance.
Right, where the computer adapts the difficulty based on their previous answers?
Exactly. The algorithm is great in theory, but if a student lacks digital literacy or gets anxious clicking through a rigid, unfamiliar interface, the algorithm might misjudge their actual listening comprehension because they were just too stressed by the software. We constantly have to guard against measuring the wrong construct.
Which brings us to our core synthesis for this explainer. The text states, effective listening assessment requires a clear definition of ability, well-designed tasks, appropriate spoken texts, and careful consideration of contextual factors to produce valid and fair evidence.
For me, it all comes back to defining that ability. I can't just broadly test listening. I have to explicitly know if I'm testing gist, detail, or inference, and map the format directly to it.
And my biggest takeaway is ruthlessly filtering out those external variables. If I don't control the speech rate, the audio quality, or the reading load of a multiple-choice question, the evidence I get isn't fair or valid at all.
We've covered a tremendous amount of academic ground today, from the cognitive strains of Field's 5 levels to the washback effects of poor task design. So, I want to leave our postgraduate listeners with a direct challenge. Look at the assessments you're designing right now. Based on these cognitive and contextual variables, how will you adapt the audio selection and task formats in your next listening assessment? Will you reduce the speech rate for your beginners? Will you switch from a reading-heavy multiple-choice test to an information transfer task to isolate the listening construct? A fantastic, provocative question to end on. Take a moment to really consider how you'll apply these frameworks. Thank you to our brilliant co-hosts, and thank you all for joining us on this explainer as we decoded Chapter 7. Keep analyzing your constructs, keep refining your tasks, and we will see you next time.